In this learning objective, we're going to continue to use SOHCAHTOA, but instead of writing our ratio, we're going to use the ratio to solve an equation. Right, so our previous learning objective, we learned SOHCAHTOA. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. The important thing is once you have this thing, it creates an equation. And when you have an equation, you can solve for something that you don't know. So if I knew sine and I knew the opposite side, I could use that to solve for the hypotenuse, for instance. All right, so we're going to use this SOHCAHTOA equation in order to solve for something that we don't know. All right, so here I would define this x value as just this missing side length that we don't know. We can't use the Pythagorean theorem to figure out the missing side because you need to know two sides, or we're missing two sides. So we only have one side of this right triangle, so we can't use the Pythagorean theorem. But what we do have is we have an angle and we have a side length. So we can use SOHCAHTOA to our advantage. All right, the first thing is to identify what sides of the triangle do I have and do I need. So again, if we go through the process, this is the hypotenuse, this is the adjacent side, and this is the opposite side. So if I look at the angle that I actually know, which is 17 degrees, I have the opposite side and the hypotenuse. Let me just quickly write SOHCAHTOA up here. And if I have the O and the H, I'm going to use sine for the trig function. So you're going to choose your trig function based on which sides you have and you need. So let's see what our equation is going to be. Our equation is going to be, we're using sine because of the ratio of sides. The angle always goes in the parentheses. So 17 degrees is going to go inside the parentheses of my sine function. And it's equal to the ratio of the opposite side, which is 4.5, over the hypotenuse, which is the thing we don't know, is x. There's kind of two options. You could kind of use the calculator early or later. I tend to use it later. So what I'm going to do is try to solve this equation for x and multiply both sides by x. That's going to give me x sine of 17. You don't have to write the degrees every time. Equals 4.5. If I want to get x by itself, right now x is being multiplied by sine, so I'm going to divide both sides by sine of 17. All right, so now the x value that I'm looking for is 4.5 divided by sine of 17. And here's where I'm going to use the calculator. All right, so here's, all right, if you're using Desmos or like your graphing calculator, your calculator has a button that says sine. Desmos, you just type in SIN for sine. So I'm going to type in 4.5 divided by sine of 17. And if I just do that right when I open up Desmos, I get negative 4.68. And you might look at this and say, well, that doesn't make sense, and it shouldn't make sense, right? Because x is the hypotenuse, and it's the length of a triangle, so it should definitely not be negative. So this doesn't make sense. All right, and the reason for this is there's different settings for your trig functions. There's two main settings. There's a setting called radians, and there's a setting called degrees. All right, we'll talk about radians in Unit 11, but we don't want to use radians. We want to use degrees. But because radians is the more common thing for math, most calculators start in radians, so you have to remember to switch it to degrees. All right, so if you have a handheld calculator, use the kind of mode button, and you can switch from radians to degrees. If you're doing it in Desmos, you use the wrench in the top right. So if you go to that wrench in the top right, at the bottom of that drop-down box, you'll see radians and degrees. So make sure you click degrees, and that'll change your answer to this problem to 15.39. And that makes a lot more sense because it's a positive number. All right, so that is our answer for that missing side when we do the trig function correctly. All right, here's another example. All right, find the missing side and round the two decimal places if necessary. Chances are it's going to be necessary because we're using a calculator. Again, we have our angle that's given to us. All right, so I'm always going to use the angle that's given to us and label our sides: hypotenuse, adjacent, and opposite. All right, so the side I have is the adjacent side, and the side I want is the opposite side. So if I look at SOHCAHTOA, which one uses the O and the A? It's the last one, tangent. So it tells me for this problem I'm going to use tangent of my angle 39 is TOA, so opposite over adjacent. I'm trying to get x by itself, so the first thing I do in all these problems is get rid of the fraction, in this case multiplying both sides by 30. And that cancels out to just give me x. So in this case, a couple less steps in the last problem. I just have 30 tangent of 29, and that I can just type in 30 tangent of 39. And that's 24.29. And so 24.29 is that missing side here that we're looking for. All right, I think we're just going to do one more example together, and then you'll do one on your own. But again, you could always pause the video and try it on your own prior. All right, but we have our angle, and we have the opposite side, and we want to find the hypotenuse. So this is another case where we're going to use sine. So sine of 59 equals opposite over hypotenuse. And our first step when we're solving these types of equations is multiply by the bottom of the fraction. So the fraction goes away. And then we want to get x by itself, so now I'm going to divide by sine of 59, so it cancels out on the left. And it goes over to the right. So now I have x all by itself. It was 45 over sine of 59. And again, just type that into a calculator. 45 divided by sine of 59. Nice thing with Desmos is you just type it just like you write it. Again, if you have your calculator in the wrong setting, you'll get 70 as your answer. But if you have it in degrees, right, because we're using an angle in degrees, you're going to get 52.50 for your answer when you round correctly. All right, so here's one for you to try on your own. All right, try to find the x in this problem. The answer you get, actually, when you end up rounding, you actually get exactly 35.00. All right, when you round correctly. All right, this one, we had the opposite side and the hypotenuse, so we use sine again. All right, we didn't do any cosine examples, but if this 30 was here, you basically do the exact same thing with cosine instead of sine. All right, but make your trig equation based on the angle you're given and the side you have and the side you want, and then solve that equation for x, and then put your answer in the calculator. All right, so for this learning objective, you're going to complete some problems on Delta Math. You're going to complete 6 total problems, but they're the exact same types of problems we just did in this video.